Hello guys, today we're gonna do some tasks about engineering mathematics 2, and we want to present topic 2.0, differentiations. My group member has 4 students and all of them is DPB. Firstly is Muhammad Fikri Al-Farid bin Sairi, 08 DPB2 2002, and secondly is Muhammad Faris Hakim bin Muhammad Firdaus, 08 DPB2 2028, and thirdly is me, Muhammad Aizat Nabil bin Rosihan, 08 DPB2 2008, and lastly is Muhammad Nur Hafiz bin Salahuddin, 08 DPB2 1092. The table of content has 7. Firstly is introduction of differentiation. Second, question stationary point of curve. Third is answer stationary point of curve. And fourth, introduction rate of change. 5, question rate of change. 6, answer rate of change. And lastly is conclusion. Okay, firstly about introduction of differentiation. What is a differentiation equation? It is an equation involving an unknown function and its derivative. And the highlight point is unknown function. Unknown function is solution. Okay, for example, dy over dx equal to x, dy over dx equal to y, and then y prime plus x equal to 0. Inverse, a function y x, whole derivative is x, a function y x, which derivative is itself. Okay, differentiation is all about finding rates of change of one quantity compared to another. We need to differentiation when the rate of change is not constant.
Okay, Assalamualaikum. Today I will talk about application of differentiation. Stationary points are points on a graph where the gradient is 0. A stationary point can be any one, like a maximum, minimum or inflection point. After that, to determine the stationary point is a maximum, a minimum or a point of inflection, we must apply the second order derivative.
Hi, my name is Muhammad Hafiz and I will present example question of stationary point. Alright, I will read the question first. Given y equal to 5 plus 3x power 2 minus x power 3, find the stationary point and sketch the curve. Alright, so we will go to the step 1. First, we need to find the gradient at any point on the curve by finding dy by dx. So we will differentiate dy over dx and we will start by differentiate 5 and we will get 0. Then we will differentiate 3x power 2 and we will get 6x. Then differentiate x power 3 and we will get 3x power 2. Alright, now we will go through to the step 2. Now we will need to find the stationary point. Stationary point dy over dx equal to 0. Therefore 6x minus 3x power 2 equal to 0. Now each term is divided by 3 and we will get 3x in bracket 2 minus x equal to 0. Then we will get 2 stationary point here. That is x equal to 0, then x equal to 2. X, we will need to substitute x in equation 5 plus 3x power 2 minus x power 3. When x equal to 0, y is 5. When x equal to 2, y is equal to 9. Therefore, stationary point is at 0, 5 and 2, 9. Next is step 3. We will have to determine the type of stationary point, whether it is maximum point or minimum point. Now we will write again dy over dx equals 6s minus 3x power 2, and we will use second order derivative, and we will get 6 minus 6x. After that, we will substitute s in equation 6 minus 6s. Then when s equal to 0, we will get 6. Therefore, stationary point of 0, 5 is minimum point. Then when s equal to 2, we will get negative 6. Therefore, stationary point of 2, 9 is maximum point. For the step 4, we will have to sketch the graph. This is the curve that we get from y equal to 5 plus 3x power 2 subtract x power 3. There is 2 stationary point here, which is 0, 5, that is minimum point, and 2, 9, that is maximum point.
Okay, I want to intro about rate of change. The rate of change is one of the essential characteristics of a function. A function describes what the relationship is between two quantities. The rate of change tells us how one quantity changes as the other change. Rate of change are everywhere. Okay, however, one of the more important application of derivative in real problem is to calculate the rate of change. Differentiation allows us to find rate of change. For example, it allows us to find the rate of change of area with respect time.
Hi, I'm Fikri. Today, I will discuss the question of the rate of change. The question is, the size of a cube is increasing at the rate of 8 cm per second power negative 1. Find the rate of increase of the volume when the length of a side is 3 cm. Okay, firstly, we must to write down all the information given. To find the volume, we must to multiply x times x times x because we don't know the length, width, and height. So, x times x times x equal to x power 3. We must to differentiate x power 3 equal to 3x power 2. Next, write down the formula of rate of change dv over dt equal dv over dx times dx over dt. Then, enter the value. We have 24x power 2. Then, when x equal to 3, we must to change the x, like dv over dt equal to 24 times 3 power 2. Solve it, and we have 216 cm cube per second negative 1.
In conclusion, in this topic we get differentiation can be defined as a derivative of a function with respect to an independent variable. Differentiation in calculus can be applied to measure that function per unit change in the independent variable. One, we can find the dy dx for the equation of the curve using rules of differentiation. We will know to finding stationary point and also learn to sketch graph. Lastly, we can find the dv dt by using the rate of change method.